Hey, great morning, friends. We are here to take a look at our last section in Chapter 8. We're going to look at factoring what we call special cases today. There isn't any new concept, really. We're just going to be looking at finding two binomials that multiply to give us a um, special type of trinomial. The first type that we're going to look at are what we call perfect square trinomials. Now, the reason these are perfect square trinomials is if you look at the last number, 49, 4, 225, 25, all of those values are perfect squares. So that's going to be our tip-off, meaning, let me take a half step back. If you take the square root of these numerical values, remember, if you take the square root of a perfect square, it's a whole number. So 49 square root is 7, 4 square root is 2, 225 square root is 15, and 25 square root is 4. So as I look at the first example here, I am trying to find two binomials here. To get x squared, I'll go x and x, and then two numbers that multiply to make 49 and add to make 14 are 7 and 7. So the tip-off here is that 49 square root is 7, and 7 plus 7 is 14. So what's special about this is that my two binomials are identical. So what I'm doing is taking x plus 7 times x plus 7, and what's special about this is you can write it as x plus 7 squared. It is not wrong if you leave it as x plus 7 times x plus 7, but just know that you can write it as x plus 7 squared. Second example, same kind of story here. The difference between examples 1 and 2 is that my middle value, the b, is a negative 4. So two numbers that multiply to make positive 4 but add to make negative 4 would be negative 2 and negative 2. X minus 2 times x minus 2, because negative 2 times negative 2 is positive 4, and then two negative 2's added together make negative 4. And again, why that's special is because it is x minus 2 times itself, so you can write it as x minus 2 squared. Example 3 is similar to numero uno in that I've got two positive values. So I'll get my x's started up here, and then two numbers that multiply to make 225 and add to make 30. Again, check if your last number is a perfect square. Square root of 225 is 15, and 15 and 15 add to 30. So I think you're probably getting the hang of it here. X plus 15 times x plus 15 can be written as x plus 15 squared. Again, either answer is acceptable, correct, all good. Last one, just so nobody gets sick, we want you to stay healthy. Two values that multiply to make positive 25 and then add to make negative 10. We've got negative 5, negative 5. Again, that can be written as x minus 5 squared. Isn't that great? Wow. All right, the last part here, and you might be looking at your note sheet saying, hey, there's a third section. Factor out a great GCF, greatest common factor, and then factor. Put a big X through it. We're going to keep it short and sweet here today. Now, the next section here is probably my personal favorite. Notice here, I have some key words. Difference, which in our little math world, difference means subtracting. So notice subtraction, subtraction, subtraction in all four examples. And it's the difference of 2. Notice we only have two terms all the way through squares. So most of the time we see a x squared plus some x plus 49, like in example 1, but here we just have an x squared, but there's no x to the first power. So another way you can write this is x squared plus no x's minus 9. And I think that's going to help illustrate this first example. You're thinking, well, how do you get two binomials to make a binomial? Well, what we're looking for, again, are two numbers that multiply to make -9 and then add to make 0. So, if I go +3 and -3, 3 times -3 is -9, and then +3 take away 3, 3 and -3 make 0. So this is my correct factorization. And I'll prove it to you by doing that four-letter F word, not fart, but FOIL, x times x, x squared, x times -3, -3x, 3 times x is 3x, 3 times -3, -9, so the -3, +3, x, those cancel out, and I'm left with x squared minus 9. Isn't that great? Wow. So to summarize it, I'm going to take the square root of the first term. Square root of x squared is x. Square root of 9 is 3. 1 plus, 1 minus, so that when I FOIL, the middle terms are a positive and a negative, and they cancel out to make 0. Amazing. So let's put it into fast forward here. M squared square root is m, and then two numbers that multiply to make -81 add to make 0, +9 minus 9. M times m squared, 9 times -9, -81, and the positive 9m and -9m will make 0m in the middle. It's beautiful. We got a 4y squared. 2y, 2y. 121 is 11, 11. 1 plus, 1 minus, and life is good. Here we have our number first, variable second. No big deal. Since the 64 is listed first, we'll take 64's square root, 8, 8. A squared square root is a. 1 plus, 1 minus, and it's a beautiful thing. So there we have it, a couple special cases for you today. Again, perfect square trinomials and difference of two squares. Enjoy, and congrats, you're almost done with factoring.